Okay, I'm going to take you through one more example. This example is going to require you to use the conjugate in that last bullet point from I believe it was the second video of strategies I gave you. So the identity reads 1 minus sine x over cosine x is equal to cosine x over 1 plus sine x. Remember, I draw a line right through my equal sign, so I remember not to add, subtract, multiply, divide both sides of this identity. We're trying to verify that the right side is equal to the left side. So this is where you would pick a side to work on. You can really work on either side, but I'm going to highlight the conjugate concept here. So the denominator of the right fraction is 1 plus sine x. The denominator's conjugate is the same first term and then the opposite of the second term. So we have 1 minus sine x as the conjugate, and I'm going to multiply the numerator and denominator by 1 minus sine x. I know it seems a little weird, but in doing that, the product in the denominator will eventually become a Pythagorean identity, which is what you want to try to simplify. So we're going to distribute the term in the numerator on the left to both terms in the numerator on the right. And then same thing, we're going to distribute both terms in the denominator on the left to both terms in the denominator on the right. In doing so, cosine times 1 is cosine x here. Cosine times negative sine x is negative cosine x sine x. Not much you can do about that. And then in my denominator, this value right here has actually been simplified. So you're going to FOIL and you're going to get 1 times 1 is 1. The outer product is negative sine x. The inner product is positive sine x. They negate to 0. And then the last product here, sine x times negative sine x, is negative sine squared x. 1 minus sine squared x is a manipulation of the original Pythagorean identity. So this denominator now is actually equal to cosine squared x. So now I have cosine x minus cosine x sine x over cosine squared x here. At this point, this is where factoring is going to come into play. So in my numerator, I have two terms, cosine x and then minus cosine x sine x. Both terms contain a factor of cosine. I'm going to factor cosine out of both terms right here, which leaves me with 1 minus sine x. Please note 1 minus sine x is not a Pythagorean identity. There's no square on the sine x here. But what's nice about this is this cosine x in the numerator here and this cosine squared x in the denominator here contain a common factor of cosine x. So I'm going to simplify that by a factor of cosine x, and that'll leave me with cosine x in the denominator, and my group in the numerator is 1 minus sine x, which is exactly what I'm trying to verify on the left here. So now I have 1 minus sine x over cosine x is equal to 1 minus sine x over cosine x. And this is an example of how we use the conjugate, which you'll have to pull out on question number 5 as well to work through this.